Alright, so we're going to talk about two chapters this week. Chapter 2, which is frequency distributions, and Chapter 3, which is measures of central tendency. Okay, so just a brief review from what we talked about last week. We talked about population versus sample. So the population is the broad group to which you want to generalize your findings back to, and your sample is the group that you did your experiment with, or you sent your survey to, or whatever. The smaller group that's going to represent the broader population. We talked about nominal, ordinal, interval, and ratio variables. Categorical is the same as nominal. We talked about quantitative and qualitative variables. We talked about experimental and non-experimental research designs. We did a little PEMDAS, and we talked about the difference between, well, sigma is an operator, meaning sum, and these are Greek letters, which are parameters. And the Latin equivalent, when you see an M or an S, those are statistics. The sample size, the smaller sample size, and X is a score. Okay. So the first thing we're going to talk about is frequency distributions. Once you've collected data, you want to display the data. The first thing we do is we look at the descriptives, right? We're not doing inferential statistics yet. We're looking at what do we have in our data set. And so we might calculate the means, we might draw some graphs. One of the first things that we could do is to construct a frequency distribution. So this is for categories, so we're looking at nominal variables when we're doing a frequency distribution, right? We're looking at the number of discrete observations, either of people, gender, race, ethnicity, language status, those nominal variables that we use where we just denote a number to represent a category. So a frequency distribution table consists at least of two columns, one listing categories on the scale of measurement, which is the X score, and another for frequency, which is the F. In the X column, values are listed from highest to lowest, although I think SPSS does it in the reverse, but it's the same thing. And then for the frequency column, tallies are determined for each value, and the sum of the frequencies will equal the sample size. So for example, if a school district allows 10 sick days per year for teachers, and we have a total of 50 teachers, we can keep a tally like this of this teacher took 1 sick day, this teacher took 2 sick days, this teacher took 1 sick day, or we can do it as a frequency distribution. So we have 1 person took 0 sick days, 4 people took 1 sick day, 5 people took 2 sick days, and so forth. If you sum the frequency, all of these, that will get you back to your sample size. So 50 faculty members, everyone gets 10 days of sick leave. So we start with 0, because some people could possibly have taken no sick days, and go all the way up to 10. If we sum this column, we get our sample size. So we can find the mean by using our frequency distribution. And the only dot I could find was this massive dot here, but that represents multiplication. So if I multiply the score times the number of people who had that score, and I get a total, I would sum the total and divide by the sample size, and I find that the average sick days for this group of teachers is 4 sick days per year. I can use this to also find the percentage. So if I take the frequency and divide by the sample size, I can find the proportion and then multiply that by 100 to get the percentage. So I take the frequency divided by the sample size, I get 0.02, and that's 2%. 2 divided by 50 is 0.04, is 4%, and so forth. If I sum all of these, I should get 100, and I in fact do. So in addition to the tables, we can also make frequency distribution graphs. Okay, when the scores are the score categories consist of numerical scores from an interval or ratio scale. We could do a histogram or a polygon. So in a histogram, a bar is centered above each score, and the height of the bar corresponds to the frequency, and the width extends to the real limit so that the... Alright, so in a frequency distribution histogram, this is what they look like. And this is a regular frequency distribution, and this is a group frequency distribution, where in a regular, each score along the x-axis represents 1 bar, and here we have children's height in inches, and it's a span, so it goes from 30 to 31, 32 to 33, and the bars touch. Okay, here's the distribution here. So 2 people made a 5, 3 people made a 4, 4 people made a 3, etc. And the same here. We're not going to do these by hand, we're going to use SPSS for this. A polygon is essentially the same thing, where you put a dot in the middle of each of these bars, and then take away the bars and draw the line. And this is what they look like. And these graphs are useful when you're comparing distributions or for showing cumulative frequency distributions, but we won't use these very often. I just wanted to show them to you. Okay, a bar graph is when we have nominal or ordinal scale variables. So the difference between a histogram and a bar graph is that in a bar graph they don't touch, because these are unique, right? They don't, if I like comedies versus dramas, they're not the same, and so each bar represents its own category. Okay, so graphs for population distributions. When you can obtain an exact frequency for each score in a population, you can construct a frequency distribution, but sometimes, like, the population of the United States is too big. We can't know how many, we can't even barely get a census figured out for the whole country, so we just base it on relative frequencies. And so when the exact number of individuals is not known, population distributions can be shown using relative frequency, which is how often something happens divided by the all possible outcomes. So using census data, we know that there are slightly more females than males in the United States, and so this is a relative frequency. And again, it's a bar graph, and they don't touch because they're individual, unique categories. And then smooth curves. It's if we look at this polygon, right, if I were to smooth that out, right, and take away the bumps, that's what this is talking about. So if the score and the population are measured on an interval or ratio scale, it's customary to present the distribution as a smooth curve. They're called splines, actually, rather than a jagged histogram or polygon. The smooth curve emphasizes the fact that the distribution is not showing the exact frequency for each category, and the one we're most familiar with is the normal curve, right? This is a smooth curve, and typically when you see this, you're talking about a population distribution instead of a sample distribution, because the sample distribution will be a histogram. So describing frequency distribution. So researchers often simply describe a distribution by listing its characteristics, and there are 3 that we talk about: shape, central tendency, and variability. So right now we're talking about the shape, and the next chapter, which we'll cover today, is we're going to talk about central tendency, and then the following chapter we'll talk about variability. So central tendency measures where the center of the distribution is located, the shape is what the distribution looks like, and then variability measures the degree to which the scores are spread over a wide range or whether they're clustered close together. So a graph shows the shape of the distribution, and the distribution is symmetrical like the normal curve if the left side of the graph is roughly a mirror image of the right. And then we have skewed distributions if the scores tend to pile up. It's easier to see it than to read it. So here we have a left skewed or negative skewed distribution. Why is it called negative skewed? Because the tail, so this is the tail, the skinny long part is to the left of the graph. And if we go past 0, it goes toward the negative side of the number line. Some people say it's skewed to the left, or they also say it's negative skewed. And then if you notice this heavy black line here, this is the average, and it's to the left of the peak. Okay, so the normal distribution has no skew. It's not skewed, it's perfectly symmetrical, and the mean is exactly at the peak, whereas the right skewed distribution has the long tail on the right hand side or in the positive direction, and the mean is also on the right side of the hump. One way to remember that is that the mean dog chases his tail. So the mean goes toward the tail, so it's on the right side of the hump. And then there's something that's not in the book, but I want you to see it because we talk about skewness and kurtosis. as a measure of normality later on in the semester, and I want you to just know what kurtosis is. It's the peakedness of the distribution. So you'll never see this again. I just want you to be familiar with this term. So elliptokurtic is a very high peak. Meso, kind of like in the middle, is a normal distribution, and a platykurtic is this flat, like a plateau. But you don't need to remember that. And then the last thing that they show us in the text for this chapter is a stem and leaf display. And rather than read all this to you, I'll show you. So each score is divided into a stem consisting of the first digit or digits and the leaf consisting of the final digits. The resulting display provides an organized picture, and I'll show you one. So here is the data, and if I line them up, I have 3, and so this is the tens place, so I have 132 and 133. And if I go find it, here's my 32, and here's my 33. I have a 42 and a 46. Here's my 42. Here's my 46. So here, this is how they all line up. If I take this and turn it on its side, I have my histogram. You know, I tried to smooth it out a little bit with my cursor, but SPSS will give us this. We have to uncheck it so that we don't deal with it. I just wanted you to see what it was. We won't use it in the class very much. Okay, so now we're going to talk about measures of central tendency. It's a statistical measure to determine the single score that defines the center of a distribution. So the goal of central tendency is to find the single score that's most typical or most representative of the entire group. We call this the average or typical individual. It can then be used to provide a simple description of an entire population. One of the reasons why we have different ways of doing this is that there's no single measure that produces a central representative value in every situation, and there can be some problems to finding the center of a distribution, so we talk about the mean, the median, and the mode. Alright, so the mode is the most frequently occurring score in the distribution. So here we can see that it's 12. The median is the middle number found only after numbers are listed from least to greatest. So here we have a list of numbers. If I put them in order, I can see I have 5 numbers on this side, 5 numbers on this side, so the number in the middle is the median. If there's an even number of data, then you take the 2 middle numbers and take the average of them. Outliers do not affect the median. The mean is the most common measure of center, but it's also called the average, but it's very sensitive to outliers. You add them all together and you divide the total by how many observations you have. And this is how we do it statistically, how we write it out, and I'll show you the next one. So here's the mean. This means sum, each individual score, and then divide by the sample size. So if we have these numbers, I add them all up and divide by 5, and I get 22.6. Now there's something that the mean does that is a little bit detrimental for what we want it to do, so we have to do some extra things to it. But the first thing I want you to know is that the biggest property of the mean is that the sum of all the deviation scores from the mean is equal to 0. What do I mean by that? So if I take this first 13, this first score, and I subtract the mean, this is a deviation score. This is how much this is different than this. If I take this one and subtract the mean, I get this number. Do that for all of them. If I add all these up, they come to 0. Okay, well that's not helpful if I want to use that to divide or multiply by anything. So I just want to reiterate, a deviation score is the individual score minus the mean. Okay, so one of the ways we get around this feature of the mean is that we square it, okay, and then we can later on unsquare it or take the square root of it. So we just take the individual score minus the mean and square it. And I'm just going to say that for now. We'll talk about it more in the next chapter. So when we include an outlier, the mean increases. So if I have 9 plus 8 plus 7 plus 5 plus 1 divided by 5, that's 30 divided by 5, which is 6. So the mean is 6. If I change this 1 to an 8, my average goes up. So anytime you have an outlier, it affects the mean. Alright, so I've already shown you this in a previous slide, but briefly, it's just to recap. these are the frequencies of the scores. So if I multiply 10 times 1 and I get the f of x, the frequency of that score, and I get 10, 9 times 2 is 18, 8 times 4 is 32, 7 times 0 is 0, 6 times 1 is 6. I get the frequency, the product of the frequency times the score, which is 56. I take the frequency, and that is my sample size, so I say 56 divided by 8, and that is my average. All right, so when do we select which measure? So typically we prefer to use the average when we're talking about test scores. We would want to use the median when we have extreme scores or we have skewed distributions. We typically use median scores for housing prices or for income because those can have outliers, and so we want to know with the median. Also with age, depending on what the outcome measure we're looking at. And then mode is the most frequently occurring score of a distribution. So there are times when we use that, but the one we use most commonly is the mean. All right, in summary, so we talked about frequency distributions, we talked about visualizing our data with bar graphs, histograms, and polygons, and we talked about measures of center, the mean, the median, and the mode. And next we're going to talk about variability.